Okay, Assalamualaikum. Right, so this video, we will continue with the role of phytochrome, and also photoperiodism. Okay, what is basically phytochrome? Okay, so phytochrome and the effect of light on flowering. Okay, phytochrome is photoreceptor located in plants that responses to the light. Okay, so phytochrome consists of protein covalently bonded to non-protein part that function as chromophore. So chromophore is the light-absorbing part of the phytochrome molecule. The chromophore is photoreversible from PR converted to PFR. Okay, so P here stand for phytochrome. R or PR over here referring to the light that they absorb. R stand for red light and PFR stand for far red light. Okay, let's see this picture. Right, so this is the structure of phytochrome. Remember, phytochrome is consisting of protein covalently bonded to the non-protein part that known as chromophore. So this is chromophore. So this is the non-protein component. And these are the protein component. Okay, so chromophore act is light absorbing part of the phytochrome. Okay, right. So what happened actually? Okay, PR absorb red light. So phytochrome red absorb red light and it will be converted into PFR. Okay, and PFR absorb far red light and then converted into PR. Okay, so I'm going to write this. PR is photoreversible to PFR. Right? So PR is in active form. And PR is active form. What does it mean by active form? Active form is the one that will induce the plant responses. Example, flowering. Okay, right. So we need the PFR level that will induce either the plant to be flower, germinate, or whatnot. Right? Okay. So this interconversion between isomer act as switching mechanism that will control the various inducing event in the life of plants, like triggering or inhibiting flowering, germination of seed, setting internal clock, inhibition of vertical growth, all right, vertical growth of plant, and stimulating branching of plant. All right, so this is how the interconversion between PR and PFR will induce many activities in the life of the plant. Okay, so you can see from this picture, so this is the inactive form of phytochrome red. Phytochrome red will absorb red light. So red light is between around 6600 nanometer. Then it will be converted into short-lived intermediate form and converted into active form, which is PR. Okay, right. So the active form PFR. Okay, so PFR will induce many physiological responses of plant like flowering. Okay, so next is the PFR also degraded, right? Will be degraded as it absorbs far red light. So far red light is around longer wavelength compared to red light. So around 730 nanometer, right? And the PFR will be degraded and then converted into PR, right? So macam itulah. Okay, so you can see when the phytochrome absorb red light, it will be converted into PFR. So level of PFR will induce the plant responses like flowering. PFR level will decrease as the PFR degraded, right? As it absorbs far red light. So the conversion of PFR to PR usually happen in darkness, and the process is quite slow, right? So to sum up, right, you have your PR, right? Here is the PFR. So the conversion of PR to PR happen mainly in the daylight, right? As it absorbs the red light. Okay, so phytochrome red absorb red light, right? And the conversion of PR to PFR is rapid. Okay, as for PFR, then it will be converted into PFR. PFR is active form, which will trigger many events of the plant's life, like flowering. So next PFR then will be converted to PR, and it happened during in darkness. So I'm just put some symbol over there, moon, to show that there is a nighttime ataupun in the darkness. So the process of conversion of PFR to PR is slow. Okay, so this rapid and slow interchange between PR and PFR is very important, which I will explain you later. Okay. All right, so thus this is the differences between the two phytochrome, PR and PFR. So phytochrome red is the red light absorbing phytochrome, which absorb red light with relatively shorter wavelength, around 660 nanometer. Madam kena hafal ke wavelength ni? Hafal. Okay. And PR is the inactive form, whereby PFR is far red light absorbing phytochrome, which absorb much longer, longer wavelength, which is around 3730 nanometer, and PFR is the active form. Right? So this is the difference between the two phytochromes. Okay, next. The PFR form triggers the plant development responses to light. Remember, since the PFR is the active form. Okay, in darkness, the phytochrome ratio shifts gradually from PFR to PR. Remember, in darkness, PFR will be degraded and then converted into PR. Okay, right. When sun rises, okay, remember in the presence of sunlight or light, okay, that contain both red and far red light, so PFR level will suddenly increase. Why? Because remember, the conversion of PR to PFR by observing red light is a rapid photoconversion. So PFR level will increase. Sebab apa? Remember, waktu siang ataupun with absorbing red light, so PR will be rapidly converted into PFR. So your PFR level will increase. Okay, right. So the ratio of PFR to PR will increase in the sunlight. Maksudnya, if you compare your PFR concentration or PFR level, you is higher compared to PR in the daytime or in the presence of light. Okay, right. Okay, the sudden increase in PFR each day at dawn will reset the biological clock. So physiological response to photoperiod such as flowering is known as photoperiodism. Okay. So actually the night length, not the day length, that will control flowering of plant and other responses of photoperiod. So this is something that you have to take note, right? It's actually the night length that will actually control what is going to happen or what kind of responses of plant towards photoperiod. Okay, so to understand this, right, you have to know that each plant actually have their own specific critical night length, right? So the actual number of hours in the critical night length is specific to each species of plant. Critical night length means a certain period that is somehow set ataupun must be observed by each particular plant, and each plant species have different critical night length. Okay, all right. Okay, so thus we have three or four different type of plants. Okay, the first one is short day plant or long night plant. Short day or long night plant. Okay, now I'm going to use this as my reference. Okay, let's say I have a time frame for 24 hours. So I put here, this is my critical period. Critical dark period. Okay. Where this critical dark period is 12 hours. All right. So this is the critical, I mean, this is the PAR, right? The standard of that particular plant. Okay, example. So for short day plant or long night plant, they requires a dark period that is equal or longer than the critical period for it to flower. Okay, listen to my word. Or you can use as, Madam, macam mana nak ingat long day, short day, long night. So remember, night time or night length is the one that will induce the responses toward plant. Flowering, for example. So nak ingat, you just ingat satu benda je. Okay, malam yang menentukan segalanya. So you just ingat, okay, long night plant. Okay, so for long night plant, this plant requires longer, continuous, dark period than the critical period for it to flower. Okay, so meaning to say, let's say I have here, right? This is the night length. This is the continuous dark period. The word here must be, the dark period must be continuous. Must be continuous, right? Let's say the continuous dark period here is, I take as 18 hours. You can see that the night length, the continuous dark period, tempoh gelap yang berterusan sepanjang 18 jam. And it is longer than the critical period. So that is the characteristic for long night plant. Long night plant requires longer, continuous, dark period than the critical period to flower. So when it meets this kind of condition, then the plant will flower. That is for long night plant, or we call as short day plant. So this kind of plant usually bloom or flower during late summer, autumn, or winter. Why? Remember, in winter, we have a very long night, right? So it is good for this plant to flower. For example, this poinsettias that is very famous during Christmas, right? Chrysanthemum and many other soybean varieties. Okay, right. So this is the first type of plant. Okay, second type of plant. Long day or short night plant. Okay, short night plant. So short night plant will only flower if the period of continuous dark period, okay, please add the word continuous, right? Short night plant will only flower if the continuous dark period is equal or shorter than the critical period. Okay, so how it's going to be represented with? Okay, let's say we still have the same critical period. Sorry. So I put the critical period is still same, 12 hours. So this plant will only flower if the continuous dark period is shorter or what I call it, equal to the critical period. So this one. Okay, so this is, you can see that, let's say this is 11 hours. Okay, so the continuous period, continuous dark period is shorter than the critical period. So then this plant will flower. An example of the plant is those plants that flower during late spring or early summer, because summer we have a very long day with short night. Okay, so example of plant, spinach, iris, okay, iris, and many cereal. Okay, next one, intermediate day plant. Intermediate day plant, the third one, intermediate day plant will only flower when they are exposed to days and night that is intermediate length, right? Like 12 hours day, 12 hours night. So they will flower when they are exposed to the same length of days and night. So they do not flower when the night length is either short or too long, right? So they are known as intermediate plant. Example, sugarcane and also coleus. Okay. And the fourth one is day neutral plant. So day neutral plant will flower when they reach certain stage of maturity, regardless of the day or the night length, and respond to the external or internal stimulus. So this kind of plant, they are called as day neutral. Tak kisahlah tempoh malam macam mana, tempoh pendek macam mana, tak kisah. As long as they get, reach to the certain stage of maturity, then it will flower. So this example, the example are like tomatoes, rice, and also dandelion. Okay, all right. So to understand this, then you have here this picture graph showing you percentage of flowering and comparing with the day length and the night length. Okay, so for short day plant, remember short day is long night. Right, short day, long night. So long night plant or short day plant will only flower if the continuous dark period is longer than the critical period. You can see when the night length is longer, right, the percentage of flowering is very high. So this is for long night plant. So if you compare with the long day plant, long day means short night plant. So they will flower if the period of the continuous dark period or the night length is shorter than the critical period or than the day length. All right. Okay. And for intermediate day plant, you can see they will flower if the the night length and the day length is in the intermediate. Okay. All right. All right. So next we go to here. The photoperiodic control of the flowering in different type of plant. Okay. Let's say you are given to you a short day plant example. So you can see this is example of chrysanthemum. Okay, chrysanthemum. Right, remember that is when you know, chrysanthemum is short day plant, right? But if let's say you're not given, what are those example? But the picture just showing you the plant is flowering or not. So you have to refer to look at the critical dark period and look at the the responses of plant towards the night length. Okay, let's say here you have the first experiment. Okay, this is chrysanthemum. Chrysanthemum is a short day plant. But if chrysanthemum is exposed to the night length that is longer than the critical dark period, it will not flower, as you can see from here. Right? Okay. But for this plant, this chrysanthemum, the second experiment, the same flower is exposed to the continuous dark period that is shorter than the critical period. Then the plant is flower. So this one is the characteristic of short day plant. But what happened here, right? Experiment C. The plant is exposed to the same length as B. But why the plant is not flowering? Okay, right? So this is a short day plant. Short day plant requires shorter, continuous, dark period. Then the sorry, I'm wrong. Okay. All right. Okay, again. So this is a dark period. Sorry. Okay, again. Okay, I repeat again. All right, so this is a short day plant. So remember, short day plant means long night plant. Long night plant. So the plant requires longer continuous dark period than the critical period for it to flower. So you can say experiment A. For experiment A, the plant is not flowering. Why? Because you can see here the dark period, the continuous dark period is shorter than the critical period. That's why it is not flowering. Okay. But as for experiment B, you can see that the plant is exposed to the dark period or continuous dark period that is longer than the critical period. That's why the plant is flowering. So this is characteristic for short day plant or long night plant. You can see sometimes we can confuse. If we are referring to short day, right? Confuse a little bit. So that's why I'm encouraging you to memorize only one name. So if you prefer for focusing on the night length, then you just focus the long night plant, short night plant, something like that. Okay, right. Next, the third experiment. The plant is exposed to the same dark period as experiment B, right? But why the plant is not flowering, right? This is because there is presence of flashlight. So what does this flashlight do? What does this flashlight do? Okay, remember syarat dia apa? The dark period must be continuous. So flash of light actually interrupt the continuous dark period. Okay, so the flash of light, even a short period of flash of light will actually affect the plant with this result, which is not flowering, because flash of light interrupt the continuous dark period. Okay, how to explain this? I will explain later. Okay, so next we go to long day plant experiment. The next one, long day plant means short night plant. Okay, short night plant. So short night plant requires shorter continuous dark period than the critical period to flower. So look at experiment A. So experiment A, the plant is exposed to continuous dark period that is shorter than the critical period. That's why it is flowering. Okay, but experiment B, when it is exposed to continuous dark period that is longer than the critical period, it will not flowering. So ni menunjukkan dia adalah short day plant, short night plant or long day plant. Okay, right. And as for the third experiment, you can see it is exposed to longer dark period than the critical period as experiment B. But why the plant is flowering? Right? Why? Because remember, it have flash of light. So again, the flash of light interrupt the continuous dark period. So what happened to the dark period? The dark period become shorter. The dark period becomes shorter. That's why the plant is flowering. Okay, so this one is very important. You might be asked with this kind of question by giving you different type of plant with the photoperiod. Okay, right? So you have to understand the effect and understand type of plants. Okay, right. Next. Okay, now let's see the explanation. Okay, long night plant. Okay, short day plant or long night plant. Remember, long night plant requires longer continuous dark period than the critical period for it to flower. Okay, so this is okay. So if continuous dark period is longer than the critical period, such as during autumn or winter, so remember the night length is longer. Remember, night length is longer. So let me use another color. Okay, night length is longer. Let's say 18 hours. So the day length is shorter, maybe around 4 hours. Okay, when the night length is longer, remember what happened at night? At night, remember the photo conversion between PR and PFR, right? When the night length is longer, right, there is enough time for the PFR to be converted into PR. Remember, PFR converted into PR at the night time. Since the night time is longer, there is enough and sufficient time for many PFR to be converted into PR. So as a result, your concentration of PFR will be lower. Okay, ingat, conversion of PFR to PR slow, lambat. Tapi disebabkan tempoh malam yang agak panjang, so banyak PFR can be converted into PR. Okay, so it will lowers your PFR. So low PFR level stimulate flowering for short day plant or long night plant. So in other words, short day plant or long night plant requires low concentration of PFR for it to flower. Okay, right. So a period of darkness can be ended by a brief exposure to light. So a flash of light interrupt the dark period and thus preventing the plant from flowering. Okay, so maksudnya kalau kita bagi a flash of light over here, the plant will not flower. Right, kenapa? Tempoh gelap dia jadi pendek. Jadi, sikit PFR convert kepada PR. So what happened to your PFR level? Your PFR level is high. So high PFR will inhibit flowering for long night plant. Okay, so Madam buat conclusion kat sini. For long night plant, okay, so low concentration of PFR will stimulate flowering. High concentration of PFR, okay, high concentration of PFR will inhibit flowering. That is for long night plant. Okay, right. Next, we go to, the next explanation. Okay, let's say, right, for still we are talking about the long night plant. If the long night plant, right, is exposed to continuous darkness that is shorter than the continuous dark period, right? So what happened? It will, contoh, we are still talking about long night plant here. So let's say this long night plant is exposed to shorter dark period than the critical period, sedangkan dia nak longer dark period, right? So what happened? Night length is shorter. So when the night length is shorter, less PFR convert to PR. Thus, you will have high concentration of PFR. So high PFR will inhibit flowering for the short day plant. So this is summarizing what that I have made here. This one. Okay, right? So it giving you two different situations. Kalau this long night plant exposed to long night length and also shorter dark period, shorter continuous dark period, what will happen? Okay, so ingat for long night plant, high concentration of PFR stimulate flowering and low concentration of PFR stimulate flowering and high concentration of PFR will inhibit flowering. Okay, like this. Okay, next we go to long day plant or short night plant. Okay, so short night plant. Remember, short night plant requires shorter continuous dark period than the critical period for it to flower. Okay, so short night plant will only flower if the continuous darkness or the continuous dark period is shorter than the critical period. Okay, right. So what happened? So if continuous darkness is shorter than the critical period, like in late spring or in summer, so night length is shorter. Tempoh gelap dia singkat. So less PFR convert to PR. Sikitlah PFR yang dapat ditukar kepada PR. Sebab apa? Tempoh gelap dia pendek. Dahlah conversion of PFR to PR tu slow. So sikitlah PFR yang dapat ditukar kepada PR. So what happened to your PFR? your PFR level is high. Sebab sikit je PFR sempat tukar kepada PR. Okay. So as the night length is shorter, less PFR convert to PR. So resulting with high concentration of PFR. So this condition, maknanya this short night plant requires high concentration of PFR to stimulate flowering for long day plant or short night plant. Okay, what if, okay, the short night plant is exposed to dark period that is longer than the critical period? Okay, what happened to this plant in autumn or winter? Okay, so when the night length is longer, we are talking about still short night plant ya, tapi kalau kita bagi dia exposure of the night length that is longer than the critical period. So what happened? More PFR convert into PR during the night time, right? And thus lower the concentration of PFR. So low concentration of PFR will inhibit flowering in the long day plant or short night plant. Okay, so madam buat conclusion kat sini. So long day plant or short night plant, we are talking about long day plant or short night plant right now. So dia nak apa? Okay, dia nak shorter continuous dark period than the critical period for it to flower, right? So tempoh gelap pendek. So sikit PFR can be converted into PR. So your PFR level is high. So high concentration of PFR will stimulate flowering. And low concentration of PFR, right, will inhibit flowering for short night plant, right? So that is conclusion that you can take from here. Okay, right. So a brief of light interrupt the long dark period. Contoh, kita dah bagi dia short night, right? Long day plant means short night. Okay. A brief of light interrupt the long dark period, which will induce the plant to flower. Okay. So shorter night plant requires shorter continuous dark period. Dia nak continuous dark period je, yang pendek. Alright. So kalau you give them, let's say, you give them exposure to longer dark period, right? Suppose it will not flower, betul? Right? Suppose dia takkan flower. Sebab remember, kalau dia punya tempoh gelap dia panjang, many or more PFR convert into PR. So then you have low concentration of PFR. So suppose it will not flower. But when you give a flash of light during the continuous dark period, so a brief of light interrupt the long dark period and then induce the plant to flower. Okay, right? Okay, so hopefully you are okay with this. Okay, so reversible effect of red and far red light on photoperiodic responses. Okay, sometimes you will be given this kind of question. One photoperiod, right, and two different plants. And the question will ask you, what is plant A, what is plant B, for example. Okay, so you have to identify the effect of the plant towards the photoperiod. Okay, for example, experiment 1. Right, this is the critical period, the critical dark period, right? And you can see the first experiment here, the plant is exposed to longer continuous dark period than the critical period. Plant A is not flowering and plant B is flowering. So definitely you know that plant B is a again, salah, right? This is a dark period, okay? So this is the critical dark period. So plant experiment 1, the plant is exposed to continuous dark period that is shorter compared to the critical period. So then what happened? Plant A will not flower and plant B is flower. So then you know plant B is a short night plant. Or long day plant. And plant A is a short day plant. Okay, so in the second experiment, Okay, when the plant is exposed to longer continuous dark period than the critical period, right? You can see that plant A is flowering and not for plant B. So this one showing you that plant A is long night plant. All right, okay. Next, we go to experiment 3. Experiment 3. So the plant is exposed to the same photoperiod, same night length as experiment 2, right? But you can see what happened to plant A. Plant A is not flowering, but plant B is flowering. So plant A is supposed to be a long night plant. But once it given a flash of red light, R here stands for red light, right? You can see that actually what happened? The plant or plant A is not flowering because flash of light interrupt the continuous dark period. So the continuous dark period becomes shorter, so the plant will not flowering. But plant B is flowering. Okay, right. Now let's go to experiment 4. Okay, in experiment 4, the same exposure has been given, right? But you can see what happened to plant A. The plant A is flowering as it given exposure to flash of red light followed by a flash of far red light. What happened actually? Why the plant is suddenly flowering, right? So this is what we call as the reversible effect between red and far red. When a flash of red light is exposed to the plant during the continuous dark period, followed by immediate exposure to far red light, so what happened is somehow showing a cancellation effect. The effect is reversible, right? So meaning that the plant detect no interruption of the continuous dark period. Plant detect no interruption of the continuous dark period. Macam seolah-olah tiada gangguan. It's somehow like cahaya merah followed by immediate of far red light, dia jadi cancel, zero. Right? So that's why plant detect no interruption during the dark period. So seolah-olah this one is totally complete continuous dark period. So that's why plant A will flowering but not for plant B. Syarat dia, it must be followed by immediate red and far red. Sepasang, a pair. Kalau red, far red, red, like experiment number 5 over here, you can see red and far red will cancel. Then you have here a single red light. So the effect will be divert. The plant is not flowering. But if you give red, far red, and red, far red, the plant will flowering. So it must be reversible between red and far red. Okay, right? Okay, next. A flash of red light during the continuous dark period, followed immediately by a flash of far red light, the plant detect no interruption of the night length. So this is what we call as far red, this is what we call as demonstrating red far red photoreversibility effect. So ini maksudnya. Red and far red photoreversibility effect. Okay, right. So that's all something related. That's all related to photo period and photoperiodism. And with that, we end with chapter 3. Okay, thank you.